These are the notes for topic 9. And in topic 9, we're going to be solving quadratic equations. We're going to start with the graphing method. Okay, tables and graphs, which is not the best, but so to graph this function, the origin is the vertex because there is no linear term. So when I plug into x equals the opposite of b over 2a, I get 0 over 2, which is 0. And if I plug in 0, I get 0 squared minus 16 is negative 16. So the vertex is 0, negative 16. And we're not going to find all the other fun stuff, again, because what we're trying to do here is solve this. So I'm going to count by 2's going down here. So 2, 4, 6, 8, 10, 12, 14. It's still not going to fit. So the vertex is going to be somewhere down here. Okay. You can't see it because it's so far away and my graph is too big. So anyway, the vertex is somewhere down here. And that's also the y-intercept. I don't know if you recall, but to find the x-intercepts, we take and we set this thing equal to 0. And that thing factors, it's the difference of two squares. It factors to x plus 4, x minus 4. And so the x-intercepts are positive 4 and negative 4. And those are the solution to this quadratic equation. We would say that x equals 4 and negative 4. Another way to write that is x equals plus or minus 4. But just because of the way it's graphed, it's easier to just find the x-intercepts and say, boom, there's a solution. Okay. So then, solve this, and it's a similar issue. When I go to graph this, it's really not going to fit on my graph paper. So that's where we talk about using, the tables instead. I could find the vertex. It's going to be x equals 14 over 2 or 7. And if I plug that in, I get 7 squared minus 14 times 7 plus 49, which is 49 minus 14 times 7 plus 49. Actually, it's not that bad. The vertex is at 7, 0. And so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. It's out here. And so anyway, what that tells us is that there's your x-intercept. Okay. When we're solving these equations, there's going to be two answers like there are here. Another possibility is that there's one answer, like what I have here, x equals 7. And we call that tangent. And at the point of tangency, we have what's called a double root. Okay. And this is probably the third possibility, which is that there's no x-intercepts. And so, here the vertex is going to be negative 3/2, and I plug that in, and I get 9/4 minus 9/2 plus 7, and 9/4 minus 9/2 plus 7 is 19 over 4, which is 4 3/4. So the vertex for this is 1, 2, 3, 4. The vertex for this is up here somewhere. And we draw in that parabola. Goodness. We draw in that parabola and we see that it doesn't cross the x-axis. So therefore this one has no real solution. It does have a solution, but it's not a real solution that I can graph. So we say it has no real solution. We can tell that from the graph if we go to find the x-intercepts. Right now all we know about solving this is factoring, and if I go to find these x-intercepts, that doesn't factor. So that's where we would have 0 answers, no answers. So solving quadratic equations, I can get no answer or no real solution. I can get one answer where the graph is tangent to the axis, or I can get 2 answers where the graph passes the x-axis. Okay. So again here, I think it's easier with the big numbers that I have here to just say, 0 equals x squared minus 36, and if I factor that, x plus 6, x minus 6, so x is plus or minus 6. Those are going to be my x-intercepts. Down here, I would probably do the same thing, because if I were to go to graph that, I'm going to be graphing fractions, and I don't want to do that if I don't have to. So does that thing factor, x squared minus 7x plus 6? I think it does. We get x minus 6, x minus 1, so x equals 6, x equals 1, and we'll explain in more detail how we get to this. But essentially those are my here 2, 3, 4, 5, 6. Those are my x-intercepts, and my x-intercepts are the solution. Okay, and so, we've worked with the physics problems, and, Anastasia's hitting the ball from the ground, and it's going to land on the ground somewhere over here. So the question is asking, how long is the golf ball in the air? And that would be, this x-intercept, and then there might be something past that, or it might have been slightly off the ground. It might be more like, more like this. But either way, it's going to land on the ground somewhere. And this is the bigger of the x-intercepts. So I have negative 5x squared plus 25x plus 1 equals 0. And we want to find out when that ball hits the ground. And looking at this, and that does not factor. What I can do, the y-intercept is 1. I can find the vertex, which would be negative 25 over negative 10, which is 5/2. And that 5/2 is going to be approximately here. And I could plug that in and find the y-coordinate. It's not what we're looking for, however. So what's happening here is, one of the x-coordinates, one of the x-intercepts is going to be, sorry, you're not seeing this. One of the x-intercepts is going to be over here. The other one's going to be to here. And they're going to be the same distance because of that axis of symmetry thing. They're going to be the same distance. The distance from this x-intercept to the vertex is going to be the same as the distance from this x-intercept to the vertex. So that's another way that we could try to figure that out. I believe this is more of a a guess and check problem. We know it's going to be bigger than 2.5, and it's probably going to be more along the lines of somewhere 3 or 4 in there. So, I mean 3.5 or 4, you know, close upwards of that. So that's how we would do that. And that is it for this section.